Facilitators International Study Channel followers, how are you? Welcome to Facilitators International Study Channel Grade 12 Mathematics lesson in Ethiopian curriculum. My name is Yamata. If you're interested in my presentation, you can subscribe, comment, like, and also share. Now, let us start our today's presentation. So, let's start our today's lesson. Our today's lesson is monotonic sequence. First, we must define what it means, the monotonic sequence. So, the definition says that, as a definition, let a sequence A and B, a sequence of numbers, B sequence of numbers. First, AN, the sequence AN is said to be increasing sequence. If AN should be less than or equals to AN plus 1 for every N should be an element of N. Increasing sequence and sequence is a sequence or it is certain functions, it will be increasing enough in enough. Let's say if for every n in n, so an should be less or equals to an plus 1. This works for all n set of natural numbers. Then the sequence n is said to be an increasing sequence. ብለን እንጠራዋለን ማለት ነው። ያ ማለት የኤን ዋጋ እየጨመረ ሲሄድ የኤኤን ቫልዩ ወይም ፋንክሽናል ወይም የሲኩዌንሱ ፋንክሽናል ቫልዩ አብሮ እየጨመረ የሚሄድ ከሆነ ይህ የተሰጠው ሲኩዌንስ ምን ተብሎ ይጠራል? ኢንክሪዚንግ ሲኩዌንስ ብለን እንጠራዋለን ማለት ነው። that means that is a sequence AN is say increasing if we can say A1 is less or equals to A2, this A2 is again less or equals to A3, again this A3 is also less or equals to A4, so A4 is less or equals to, so every n, for every n it works like this, which is AN is less or equals to AN plus 1, all this. So if this is happen for every n, the set of natural numbers n, then such kind of sequence is known as the increasing sequence ብለን እንጠራዋለን ማለት ነው። The third definition relating to this increasing sequence is said to be the sequence AN is said to be strictly increasing sequence if we can say if AN should be strictly less than to what AN plus 1. So you can compare here, if AN is less or equal to AN plus 1 for every n, an element of n, so this sequence is said to be increasing. Whereas if the sequence AN is strictly less than 2 AN plus 1, this works for all n is an element of set of natural number n, then such kind of sequence is known as a strictly increasing sequence. That means here we can say the sequence AN is strictly increasing sequence. That means if we can say A1 is less than A2, and again A2 is less than A3, and again A3 is less than A4. This works for all. This works for all these less than an plus 1 is less than in such a way. So if the sequence is having the form like this, which means an is less than a2, I mean a1 is less than a2, and a2 is less than a3, and also a3 is less than a4, a4 is less than a5, and it continues in such a way, then such kind of sequence is known as the strictly increasing bilateral series. እዚህ ጋር increasing እና strictly increasing የሚለውን በዚህ መልኩ መለየት እንችላለን ማለት ነው። On the other case, we can say the sequence, the third part says that if a sequence, we can say a sequence an is said to be decreasing sequence, decreasing sequence, if we can say an is greater than or equals to an plus 1 for all n is an element of set of natural number n. That means we can say if the sequence an is decreasing sequence, if the sequence here, if a1 is greater than a2, and a2 is greater than a3, and a3 is also greater than a4, and a4 is greater than all this, the value which is greater than an is greater than an plus 1, and this is also greater than in such a way. If the sequence is having the formula like this, then such kind of sequence is known as the decreasing sequence. In the other part, we can say the fourth part, he says that if the sequence an is said to be which is strictly decreasing sequence, if we can say an should be greater than an plus 1. For this, in the case of decreasing sequence, we can say here or greater or equals to, or greater or equals to. But in this case, if a sequence n is said to be a strictly decreasing sequence, the functional value an is strictly greater than to what? An plus 1. This works for every n is an element of set of natural numbers. That means we can say here the sequence an, that means a sequence n is strictly decreasing sequence. We can say a1 is strictly greater than to a2, and a2 is also strictly greater than a3, and a3 is also strictly greater than to a4. All this is continuous in such a way, which is an greater than an plus 1 for all these workers for every functional values. Then all this in this case we can say the sequence an is said to be strictly decreasing, and in this situation the sequence n is said to be decreasing sequence. Now, finally, the sequence, when combining either from 1 up to 4 here, we can say a sequence, a say notation here, a sequence an is said to be monotone. We can say monotone, or we can say monotonic, or monotonic, monotonic sequence if it is either increasing or decreasing sequence. እንግዲህ ምንድነው የሚለን ቶፒካችን የሚለን እዚህ ጋር ሞኖቶኒክ ሲኩዌንስ ነው የሚለው። ስለዚህ ሞኖቶኒክ እንጠቅልል አድርገን ከማየታችን በፊት the sequence is to be increasing or decreasing የሚለውን ነገር ማየት አለብን። the sequence is said to be increasing if it works for all an is less or equals to an plus 1 for every n is an element of an. In the other case, if a sequence is n is said to be decreasing sequence, then we can say an is greater or equals to an plus 1 for every n an element of n. Now, when you combine this, the third one and the first one, we can say a sequence n is said to be monotone, or we can say monotonic sequence. We can say monotonic sequence if it is either increasing or decreasing sequence. እንግዲህ አንድን ሲኩዌንስ ኢንክሪዚንግ ካደረገ ወይም ደግሞ ዲክሪዚንግ ካደረገ ያን ሲኩዌንስ ምን ብለን ልንጠራው እንችላለን ማለት ነው? ሞኖቶኒክ ሲኩዌንስ or we can say the sequence is said to be monotone ብለን እንጠራለን ማለት ነው። እንግዲህ ከሁለት አንዱ ከሆነ ማለት ነው አክቹአሊ ኢንክሪዚንግ ዲክሪዚንግ ያደርጋል ማለታችን አይደለም። አንድ ሲኩዌንስ አይዘር ኢንክሪዝ ያደርጋል or ደግሞ ዲክሪዝ ያደርጋል፣ እየጨመረ ይሄዳል ወይም ደግሞ እየቀነሰ ይሄዳል። for the n values is becomes larger and larger, the sequence functional value is either increasing or decreasing. ስለዚህ increasing or decreasing አደረገ ማለት የሲኩዌንሱ የፈንክሽናል ቫልዩ increasing ወይም decreasing አደረገ ማለት we can say the sequence is monotonic sequence, or we can say it is monotone sequence, monotonic sequence ብለን እንጠራለን ማለት ነው። ምሳሌ ስናይ መጣበታለን። increasing ካደረገ ሞኖቶኒክ ነው፣ decreasing ካደረገ ሞኖቶኒክ ነው። monotonically increased or monotonically decreased ብለን ማጥራት እንችላለን ማለት ነው ሲኩዌንሱ። ሌሎች ሲኩዌንስ ይኖራሉ increasing ካላደረገ decreasing ካላደረገ ያን ሲኩዌንስ ሞኖቶን ልንለው አንችልም ማለት ነው። በምሳሌ እናያለን ማለት ነው። ኤግዛምፕልስ decide whether the sequence is monotonic or not. First part is a part. The sequence is 8 minus 1 over n. B part says the sequence is the same function here, 8 plus 1 over n. And C part you say that the sequence is 1 minus 1 the power of say n, like this. Now we are asked to find or to show that whether or not these sequences are monotonic or not monotonic. And as is, to show the sequence an, which is equals to 8 minus 1 over n is monotonic, we must show that either it is increasing or decreasing sequence. As a solution ይሄን ለማሳየት ሞኖቶኒክ ነው ወይም ሞኖቶኒክ አይደለም ሲኩዌንሱ ብለን ለመናገር ማሳየት ያለብን ምንድነው? ሲኩዌንሱን ኢንክሪዝ ማድረጉ አለማድረጉን ወይም ደግሞ ዲክሪዝ ማድረግ አለማድረጉን ማሳየት ቻለ ማለት ሲኩዌንሱ በራሱ ሞኖቶኒክ ሲኩዌንስ ነው ወይም አይደለም የሚለውን ነገር መለስን ማለት እንችላለን ማለት ነው። The first part as a solution, A part says that the sequence an is given here 8 minus 1 over n. 8 minus 1 over n. Now from this let's see some functional values, some few terms of the first few terms of functional values of the sequence. The first part is if n is 1, we can say 8 minus 1. If n is say 2, we can say 8 minus 1 over 2. When we used to compare 80 minus 1 and 80 minus 1 over 2, this number is less than this one. So we can say 8 minus 1 is less than 8 minus 2. And again, this is also less than 8 minus, if n is 3, we can say 1 over 3. And this number is less than 8 minus 1 over 4, and continue in such a case, in such a way. So 8 minus 1 is less than, meaning n, here it is n is 1, we can say 8 minus 1 is 7, and n is 2, 8 minus half is 7.5, so 7 is strictly less than to 7.5. Therefore, we can say the first part A1, A1 is less than A2, A2 is less than A3, and A3 is less than A4. Or in general, we can say here, these are some few terms of the sequence. Generally, since we know that the n is given here, so we know that n is less than n plus 1. For any sets of natural numbers, we know that n is less than n plus 1. Now, from this implies that we can say 1 over n is less than 1 over n is I think greater than 1 over n plus 1. Now we can see here, since n is less than n plus 1 for any sets of natural numbers, so when we divide here, 1 over n is greater than n plus 1. Since we know that, we can say 2 is less than 3, we know that. So from this part, 1 over 2 is greater than 1 over 3. 1 over 2 is greater than 1 over 3. In the same fashion here, since n is less than n plus 1, we can say 1 over n is greater than 1 over n plus 1. From this, if you multiply both sides by negative, we can say negative 1 over n is less than negative 1 over n plus 1. Nothing is done here, simply multiplying both sides by negative numbers or negative 1. So here we can say our intention is how to determine this, which is say minus 1 over n and minus 1 over n plus 1. So here we are starting here, n is less than n plus 1, it works for all n, so 1 over n is greater than 1 over n plus 1. From this we multiplying both sides by negative 1, so we can say 1 over n is less than 1 over n plus 1. From this we can simplify that here, since the sequence n is 8 minus 1, which is 8 minus 1 over n is 8 minus 1 over n is strictly less than to 8 minus this part simply, which is say 1 over n plus 1. Nothing is done, simply adding some constant number, that is an equals to 8 minus 1 over n. So we can show that here 8 minus 1 over n, that means an is strictly less than to 8 minus 1 over n plus 1, that means an plus 1. Hence from this part we can say hence we can say here an is less than to what, an plus 1. This works for what, works for every n is an element of set of natural number n. Therefore we can say the sequence 8 minus 1 over n is monotonic sequence, which is increasing monotonic. So which is since it is increasing, then this sequence is monotonic sequence. Monotonic sequence. እንግዲህ እዚህ እንደምታዩት መጀመሪያ ለማየት የተፈለገው some few terms of the sequence ነው፣ ግን በዚህ ብቻ ጀነራላይዝ አድርገን increasing or decreasing ነው ማለት አንችልም። ስለዚህ to show this is in general way the sequence is either increasing or decreasing, we can say here for every n is less than n plus 1, so 1 over n is greater than 1 over n plus 1, we know this. Therefore if we multiply by negative 1 on both sides, we have get here. Now adding both sides is the same constant number, so one ይሄ በሁሉም ጎን አንድ ፖዚቲቭ ቁጥር በደምርበት የዚህኛውን ሳይን አይቀይረውም። ስለዚህ 8 minus 1 over n is less than 8 minus 1 over n plus 1. ያ ማለት 8 minus 1 over n ማለት an ነው። እንደገና 8 minus 1 over n plus 1 ማለት ደግሞ an plus 1 ነው። so this works. ያ ማለት ይሄ ማለት ምን ማለት ነው? ይሄ ማለት ምን ማለት ነው? an equals to, so 8 minus 1 over n is said to be increasing sequence, which is increasing. ስለዚህ increasing ካደረገ ማለት ደግሞ we are asked to find the whether or not the sequence is monotonic or not ነው። ከዴፊኒሽናችን ደግሞ ምንድነው ታስታውሱ ብለን የነበረው አንድ ሲኩዌንስ ሞኖቶኒክ ነው የምንለው whether increasing or decreasing መሆን አለመሆኑን ወይ ማድረግ አለማድረጉን ማሳየት ስንችል ነው። ስለዚህ እንዲያሳየነው ደግሞ ምን መሆን ያሳየነው ኢንክሪዝ ማድረጉን ያሳየነው። ኢንክሪዝ ማድረጉን አሳየን ማለት ይሄ ሲኩዌንስ monotonic sequence መሆኑን ይነግረናል በቀጥታ ማለት ነው። When we show that here for some few terms of the sequence here, if n is 1, we can say 8 plus 1. If n is say 2, we can say 8 plus 1 over 2, 8 plus 1 over 3 if n is 3. Now when you compare 8 plus 1, 8 plus 1 over 2, 8 plus 1 over 3. So 8 plus 1 is 9, 8 plus 1 over 2, which means 8 plus 8.5. Therefore, directly this 8 plus 1 is greater than 8 plus 2 is strictly greater than 2. And again 8 plus 3 is greater than, or which is say 8 plus 1 over 4 is greater than, and continue in such a way. But this is not enough to show whether or not, or to say whether or not the given sequence is increasing or decreasing. So rather than since we know that since n is less than, which is 1 over n, I mean n is less than simply n plus 1. This implies that when both divide or reciprocal on both sides, which is 1 over n is greater than 1 over n plus 1. Look, we know that n is less than n plus 1, so 1 over n is greater than 1 over n plus 1. From this, if you add both sides with the same number, with the same constant positive number, we can say 8 plus 1 over n is greater than 8 plus 1 over n plus 1. We know that this part is here simply an plus 1, and whereas this one is simply an. So an, that means 8 plus 1 is greater than an plus 1, which means 8 plus 1 over n plus 1. This for all n set of natural numbers, which is an element of set of natural number n, we can say the sequence n is decreasing sequence, which is decreasing sequences. ያ ማለት እዚህ እንዳያችሁት እንግዲህ መጀመሪያ ለሲኩዌንሱ n ኢኳል ነው 8 plus 1 over 2 የነበረው የመጀመሪያዎችን for set n is set of natural numbers የመጀመሪያዎችን ተርሞች ጥቂት ተርሞች ብናያቸው ይሄን መስሎ እናያለን ማለት ነው። ኢንዲኬት የሚያደርገን እዚህ ላይ for n is natural numbers, so n is less than n plus 1. This implies 1 over n is greater than 1 over n plus 1 የሚለውን እናገኛለን ማለት ነው። አሁን ከዚህ ላይ both sides with positive number ብንጨምርበት የተባለው ነገር 8 ነው። ስለዚህ 8 plus 1 over n still ተመሳሳይ ቁጥር both sides ስንደምር እኩል ቁጥር ከሆነ ሳይን አይቀይርብንም። ካልቀየረ 8 plus 1 over n is strictly greater than 8 plus 1 over n plus 1. ያ ማለት ይሄኛው an ነው፣ ይሄኛው ደግሞ an plus 1 ነው። ስለዚህ ምን አገኘን ማለት ነው? ይሄን እንደምታዩት this implies that an is greater than an plus 1 የሚለውን ፎርሙላ አገኘን ማለት ነው። Therefore, this implies that this sequence, therefore, hence, the sequence an, the sequence which is an is, since it is increasing, which is a decreasing sequence. decreasing sequence. Since it is decreasing sequence, we can conclude that the sequence an, which is equals to 8 plus 1 over n, is monotonic sequence. Monotonic sequence. ሞኖቶኒክ ሲኩዌንስ መሆኑን ቼክ ማድረግ ቻልን ማለት ነው። በዚህ መሰረት ሲኩዌንሱ ማየት ያለብን እንግዲህ ዲክሪዝ ማድረጉን ወይም ደግሞ ኢንክሪዝ ማድረጉን ካየን ሲኩዌንሱ ሞኖቶኒክ ሲኩዌንስ መሆኑን በቀላሉ ማየት እንደምንችል ያሳየናል ማለት ነው። The third example says that C part, say for example, the sequence an is given simply 1 minus 1 over negative 1 over the power of n over n, we can say. As you know this before, which this sequence is in a piecewise form, we can say if n is set of odd natural number, we can say the sequential value equals to 1 plus 1 over n. If n is odd natural number, and this becomes, if n is even, say for example, say 2, 4, 6, 8, we can say that this sequence is 1 minus 1 over n. If we can say if n is even value, even number. Therefore, we can say some few terms of the function. If n is 1, which is odd, the result becomes 1 plus 1 over 1, which is say 2. If n is say 2, which is even the value here, so which is 1 minus 1 over 2, it becomes 1 over 2. Now it is decreasing from 2 to what? 1 over 2. And again, if n is 3, which is odd, so the formula here, 1 plus 1 over 3, so it becomes 4 over 3. So we can observe, and again, from the first part is from 2 up to 1 over 2 is decreasing, and again, from if n becomes larger, so it again increasing from 1 over 2 to what? 4 over 3. And the next part, if n is 1, n is 2, n is 3, if n is 4, which is even, so 1 minus 1 over 4, the result becomes 3 over 4. We can observe here, if n is 3, it becomes 4 over 3. If n is 4, it becomes 3 over 4. If you add some, say for example, which is 5, which is odd, so since n is odd, we can say 1 plus 1 over n, so n is 5, so 1 plus 1 over 5 becomes 6 over 5. Look, it continues in such a case. So from 2 to 1 over 2, it is decreasing. From 1 over 2 to 4 over 3, it is increasing. So it's this sequence, we cannot say totally increasing, we cannot say totally decreasing. Hence, we can generalize the sequence, hence the sequence which is 1 minus 1 over n, which is negative 1 over n, is not monotonic sequence. ለምንድነው ሞኖቶኒክ ሲኩዌንስ ያልሆነበት ምክንያት? ሲኩዌንሱ some terms of functional value እንደምታዩትኝ አንድ ጊዜ ይጨምራል፣ አንድ ጊዜ ይቀንሳል። ስለዚህ either totally increasing አይደለም ወይም ደግሞ an is less than an plus 1 የሚለውን for every n an element of n የሚለውን ቅርጽ አልያዘም። ወይም ደግሞ an is greater than an plus 1 works for every n an element of set of natural የሚለውን ፎርም አልያዘልንም። እና ከሁለት አንዱ ውጪ ከሆነ ይሄን ሲኩዌንስ ኢንክሪዚንግ ማለት አልቻልንም፣ ዲክሪዚንግ ማለት አልቻልንም። ኢንክሪዚንግ ማለት ካልቻልን፣ ዲክሪዚንግ ማለት ካልቻልን ይሄን አይነት ሲኩዌንስ ሞኖቶኒክ ሲኩዌንስ ነው ማለት ልንችል አንችልም። ስለዚህ ይሄ this sequence is not monotonic sequence የሚለውን መደምደም እንችላለን ማለት ነው።